Nepal has reached a remarkable milestone. We are now self-reliant in cement, with 55 operating plants producing 15 million tons annually. But this success hides a growing vulnerability, as Portland cement is responsible for a whopping 8% of all human-caused CO2 emission. That is massive for just one material. The investigation reveals a critical gap. Traditional ordinary Portland cement depends on high calcium limestone, which is a limited resource. Because of this, continuous mining reduces the available reserves. Furthermore, we face a dependency trap. Nepal lacks domestic fly ash for PPC, spending $30 to $45 per metric ton on imports from India. Our kilns consume imported coal at $75 to $90 per ton to reach the 1450 degrees Celsius required for clinkering. To meet our nationally determined contributions, we must adopt low-emission technologies that reduce this economic and environmental burden. This leads to limestone calcined clay cement, or LC3. LC3 is a chemical revolution. LC3 replaces nearly half of traditional clinker with calcined clay and limestone. The typical LC3 blend contains 50% clinker, 30% calcined clay, 15 to 20% limestone and gypsum. The Sivalik region contains abundant kaolinetic clays, while the Lesser Himalaya holds vast limestone deposits, including large volumes of low-grade material currently underutilized. By heating local kaolinetic clay to only 700 to 850 degrees Celsius, we produce metakaolin. These hydrates fill the capillary pores, creating a denser matrix that achieves strengths comparable to OPC within 7 days while utilizing materials often discarded as waste. Let's evaluate the LC3 advantage against our current benchmarks. LC3 uses only half the clinker, cuts pollution by 30 to 40%, and saves fuel and saves huge amount of capital and higher profitability on long run. Technical studies show that Nepal's current rotary kilns can be adapted without making major structural changes. Old wet process kilns are especially suitable because the chains inside them can dry and break down raw clay, which reduces the need for extra pre-processing and lowers costs. However, we identified two areas for engineering focus. First, calcined clay has a high surface area, which can increase water demand. This is mitigated through particle packing optimization and tailored superplasticizers. Second, we must collaborate with the Nepal Bureau of Standards and Metrology to adopt national standards, potentially leveraging India's existing IS 18189-2023 standard. LC3 is technically credible, constructible, and demonstrably more sustainable. Field surveys have already confirmed suitable clay deposits near major factories. By adopting LC3, Nepal builds with concrete but with sovereignty, stability, and a lower carbon footprint. The future of Nepal's infrastructure is in our soil. Stronger, greener, local. The LC3.